Hello everyone, this is Mr. Ege and I'm going to demonstrate one special rocket design today. And the purpose of this particular rocket design is to create a 3D solid model that's 3D printable, and also we're going to be able to launch it create a simulation inside the inventor and launch it to a certain height. And for this purpose, okay, we need to create a sketch. So please start your inventor. And as soon as you start the inventor, please go to the tools, and under the tools, there is a document settings. Go to document settings and please find out the units. So we're changing the units to length units to millimeter. That's very important. We're going to create some part drawings, 2 part drawings, and 1 assembly, 3 drawings in this session. And all 3 of them requires the units changed to millimeters. And the mass unit will be kilogram, okay? And once you do this, okay, check around what's also available and so on, and then close. Make sure you save your work, okay, under the OneDrive. And please make sure that you properly name it, okay? So we're going to call this rocket Milky Way 1 rocket, okay? The purpose of this rocket is a little bit weird in shape, for the reason being it's going to go very, very long distance, okay? 25,000 light years to the center of the Milky Way. That's the purpose of the rocket. So it better be very weird, okay? When you say weird, the first that comes to my mind is the quantum mechanics. If anybody studied the quantum mechanics a little bit, okay, from the books, or from the magazines, everything, and you'll find that the meaning of the weird there. Anyway, first thing, as soon as you start, okay, this particular rocket IPT inventor part drawing, you need to select a plane first. And this is going to be a XZ plane, okay? And when you choose the XZ plane, and the sketch button is going to show up. Click on the sketch button, and computer will generate the sketch button. First line to draw is the vertical line. I suggest you to draw a 50-meter long line, vertical line. First line is 50 meters, okay? And what's the reason? The reason for the 50-meter long line is going to be also the revolving axis. So that's very important. It's not only the part of the rocket, it's also the axis of the revolution, okay? And there are a number of heights, different heights. And I would go and recreate several lines in addition to the 50-meter long on the exact the same location. For example, there is a line, okay, that is 5 meters, and that's 5,000 millimeters, okay? And then there's another line, okay, just from starting from. These are the lines that points out the characteristics, the features, the components of the rocket. So that's why I drew an additional lines, okay, on the 50-meter line, just so that I can mark those points, okay? So 5,000 millimeter is equal to 5 meters. Each meter is 1,000 millimeters. There is another line at the end, okay? I'm talking about the second line on the same place, another 5,000, and there is 10,000, 10-meter line, okay, and there is 9,000, 9-meter line attached to it, okay. These are critical points on the rocket so that I can find what I'm looking for, okay, and I can show you what it is by just click inside, and you'll see. I can see it. Maybe you don't see it from resolution, lack of resolution, high resolution. But there is a line here, literally, and that is 9,000 or 9 meters, 9,000 millimeters. Okay, and there is another line, okay, about 20 meters or 20,000 millimeters, okay, which is matching with the end of the rocket, okay. So this line I have selected is a 50-meter long line, but there are multiple other lines to demonstrate you to certain locations, special locations. For example, I drew an arc here, so I went to the arc command, okay, and I drew an arc using with the radius of 17 meters, 312 millimeters, okay? All right, and 17,312 millimeters is about 17 radius of, okay? And then I used a straight line from that point, okay, all the way to here. Now that particular straight line will be approximately 9 meters or 9,313 millimeters, okay? Now, maybe you are wondering how far it is from the wall or from the 0, vertical. That is 3.5 meters, okay, distance, okay, from the 0, vertical line, okay. And then, or you draw a 45 degree or minus 45 degree or 135 degree line, okay, okay, and then from here, you're going to draw a straight line. This is 9 meters. Okay. And again, we're going to have another arc here. And this particular arc, it has to have its own radius, and I can't see it right now. So I'm in the sketch, and if I am in the sketch, I should be able to give you, okay. So the radius turns out to be, happens to be 17 meters, okay? So if I give you the arc radius, you should be able to draw a 3-point arc. First point, last point, and midpoint, okay? And finally, there is another arc, again, over here. And what's the radius of this arc? Okay. 1,000, well, 1,454 millimeters, okay, or 1.4 meters approximately, okay. All right, so the distance, how far is the distance from the rocket itself is 2.4 meters from here, and this edge of the arc, this arc happens to be 5 meters. Now, I strongly suggest, encourage you to make some modifications, some designs. If you wish, I want you to be creative also. And I like to know what you're thinking about it, how you do it, and so on. These are important. All right, so what is the distance from this point to this point? Okay, we can literally
I'm not sure.
draw here. Okay, and this is 3.8 meter or approximately 3.9 meter distance, okay? So this is close power line. Make sure that line ends perfectly meet with the line ends, okay? Because when you have the line ends do not meet, computer cannot revolve it. We're gonna, in a second, we're gonna use the revolve command, okay? And the revolve command, when you finish the sketch, make sure you save it, okay? And the revolve command is right over here. Okay. And the revolution, okay, requires you to pick two things. Click here and then select the area to revolve. You need to select this area to revolve. After that, you select the profile, because this area is the area. The computer will highlight it for you. And so then select the axis. Click on the axis and select this 50-meter high line. Okay, it's going to be 360-degree revolution, and okay it. And as soon as you okay it, computer will generate the solid model. Now, to be honest with you, I worked several times on this. It didn't do the trick for me in the first time, and it's not going to do the same time. So don't be discouraged if it doesn't first time. Try and try again, and if it gives you too much hard time or too long, too many times, call me. I will help you with this. Okay, I have experience with the failures and successes at the same time. Success always follow the failure, so don't be discouraged. Uh, just call me if there's a problem, and I'm there for you to help. Okay, so this is the rocket. This is going to look like this. Okay, the rocket is going to look like that, and you can add some features if you like to. Also, okay, because we really do not have in the world of science, rocket science, we do not have a rocket that's going to go to the 25 light years ahead to the center of the Milky Way galaxy. So I suggest you to start designing, thinking about it, and actually, hopefully in your lifetime, there will be one. But it will require a lot of hard work, a lot of research, and a lot of creativity and problem solving. Okay, and I strongly urge you to do this. Okay, so once this is done, one of the things I suggest you to is go to the assembly, create an assembly drawing, just like brand new drawing. Go to your tools, okay, change your, from the documents and settings, change your units to millimeters and kilograms for the mass and for the length, okay, and you need to also select a material here. Material is very important. I selected a carbon fiber material. Carbon fibers are very commonly used in the air industry, air and space industry. They are lightweight, and their strengths are comparable to steel. And so carbon fiber it worked for me. You can just simply apply carbon fiber if you like. And also there's an appearance library here that you can change. I love blue. Blue is a good color. I guess Air Force people love the blue too. We have to use I just pick any color you like for the appearance. Carbon fiber can be painted or made in different colors. What else do we need to do? We need a launching pad as a different inventor part drawing. You learn how to create a part drawings, but I want you to discover something else. I want you to discover how to create a part drawing from inside an assembly drawing. Okay, this is what I did. Okay, so I selected an origin, I selected a material. Okay, and let me demonstrate what just this. And inside assembly drawing, and then I simply went to the inventor assembly drawing and create. Okay. Created a part drawing from inside the assembly drawing. Okay. All right. So, well, question is, how do you do that? Well, on the assembly drawing, on the upper left-hand corner, there is a command. First command is place command for the parts. But next to it, there is a create icon. You click on it, and then computer will prompt you for creating more parts. Okay. For that, you're going to do it pretty much the same way. Launchpad, call it Launchpad, and you're going to create the Launchpad, okay, on a particular plane that you choose. And I selected XY plane, and I created the Launchpad profile, but I am going to let you to do this on your own. Okay, so this is an arc. I drew a line like this, long line like this, short line, an arc in between, and then extruded this. Okay, Launchpad. Now, how much did I extrude it? Let me show you the extrusion, 25 meters extrusion, okay? Two-way extrusion, 25,000 millimeter is 25 meters, and I can make it 50, for example. 1,000, this is 50 meters, okay? And the end click here, upper right-hand corner to end the extrusion. All right. Well, both of them will exist in the assembly drawing. And the important thing is this particular launch pad, okay, must be, press the right mouse button after select, must be grounded. Why? Because it's not moving right now. We don't plan to move it. Even though Earth is moving, in the real world, okay, launching, and maybe in other application, I'm going to move it too at certain speed of the Earth's rotation. But this, in this particular case, I put a grounded, okay, and I marked it as grounded. And in other application, we can move it, but right now it's grounded. The only moving part right now is the rocket, okay? So that's why I suggest you change your rocket, angle of the rocket a little bit like that, okay? And so that you can zoom in underneath, all right? And I suggest you to select both of them like this and go to the environments, go to the dynamic simulation, okay? All right, this is going to come out. Simulation player will come out, and you're going to insert joint, okay? And then in the insert joint, you will choose, when you click on this one, there's a spatial relationship between the component 1 and component 2. Component 1 is the moving part. So I suggest you to select this area under the rocket nozzles, on rocket nozzle. And then click on the component 2, and I suggest you to select the surface of the launch pad, okay, and click. So that will generate external loads folder on the browser on the left side. Gravity should be over there, and when you click on the gravity, there's supposed to be some arrow pointing down. This did not show me on mine first time around because I set it up gravity to minus 9,819 millimeters per second squared. After I do that in the Y direction, that arrow showed up, okay? In the Y direction, this is how it worked on my example, okay? Also, you need to go to external loads and press the right mouse button and add forces. Click on the add forces and then create a force, okay, for the rocket. This too requires entering. I added, my goodness, huge number, big number, but the location, and it should be up, by the way. And the location is also critical. So I selected the same surface, and the number I use is 250 million. Yeah, 250 million newtons of force. Okay, that's a huge number. But considering the size of the rocket, which is 50 meters, okay, and certain thickness is a Kevlar. Kevlar is lightweight, but still comparable to steel. And so we need this kind of force. And I ask you to do the math also in the instructions. I have also written instructions, okay, in the folder on the Schoology. So let's give it a try and see how it goes. And let me know if you have any problems, and otherwise show me how it works. And it's supposed to look like this, pretty much. Okay, and how far it's going up? I calculated is around 500 meters. So 250 million newtons turns out to be 500. It takes it up. So based on this information, we can literally compute how much is the mass of the rocket is, total mass of the rocket is. There are multiple other ways of finding out. Thank you very much for your time. And I suggest you to, okay, give it a try and save your work also as usual on the OneDrive. Thank you.